Okay guys, I'm here with another video of Learn Tech with Mr. Tech. So this is part 2 of building a smart home device with CAD and PCBWay. So today we'll be starting to wire this setup, and if you have no idea whatsoever what is happening in this smart home device, you should check out the intro. And also consider subscribing and liking this video. And we'll first start by adding this Arduino board onto this canvas, and this is what will help us to control all the variables, all the inputs, outputs, and all the commands that we'll be using to this smart home device. And then we'll be using a breadboard. Normally people use this small breadboard, but I find this much harder due to its size being small, so I use this larger breadboard that has more space to work. Now, for the interesting parts of this design, we'll be starting with some LEDs. Now, the good thing about Tinkercad is that we can insert any number of LEDs on any number of colors. So for example, now if I put this right here, so that's red, and that I can change the color from here to any color I want. I really like the RGB, so I'm going to change it like this: red, green, and blue. In real life, when you make this, you normally don't need to use resistors, but I would really recommend using them. In Tinkercad, they have this way of making us use this by power flowing through these LEDs are higher than the voltage that they can receive. So I'll be inserting these resistors into this circuit. And the cathode is negative terminal of a LED, so the resistor goes into the cathode terminal of this LED. And if you don't know how the breadboard is wired, let me go over it quickly. So in a breadboard, the lines on this middle, the ones that I'm highlighting right now, have been wired like this. So anything connected here and here are connected to each other. And the ones on these ends, the other two ends, which has these plus minus marks on each of them, are wired like this. Like it's shown on from these green lines. So anything connected here is connected over here as well. So that is why we can connect this resistor like this. And also, 1 kilo ohm of resistance is 1000 ohms. That's too much. So what we'll do is we'll change this up to 100 ohms, and then we will be duplicating it. Control C, Control V, Control C, Control V, and so that's not in front of one of those. So now we'll be changing. You can put it wherever you want. I just like keeping them straight. Now it's fixed. And also, don't forget to give power to the whole breadboard. So we do like this. And also, if you want to make this wire like this, it's much neater. So what you need to do is click on the pin that you need, then click to the place where you want to wire to be connected. And also, color coding is very important in wiring these components. It will help us. It's going to feature into this project that will help us to identify which wire is from which. So, and also normally we use red wires for power wires such as the 5 volts, and for ground we use black wires. And like this, change colors to black, here, here. You can change this by selecting this red dot and moving it. Now, so these two lines are connected, have power of the from the breadboard, but these two doesn't. So what we do now is we connect these like that. And then we change color. There. So now the whole breadboard is powered from these two lines. So to power these parts, we use this. In order to control LEDs, we need to be able to control the power coming through them. So we can't just connect this to that, since it will have a constant flow of 5 volts into the LED. So there will be no control over it. So see, since we connected the 5 volt power to this LED, we have no control over turning it on or turning it off. So what will we do now is connect this wire to any of the digital pins on the top part of this Arduino board. Or at least if you have this Arduino board in another alignment, the part which has these numbers, this long line of numbers, not the A0, A1, those are other pins, and you will understand the purpose of those going further into this project. Since we will be having many digital pins and analog pins used in these projects, I'll be using 2, 3, and 4 for the LEDs. And connected to. Now I'll change this one's color to yellow, and then connect this one to 3, and connect that one to 4. There we have all the LEDs wired correctly. Now, to move on to the PIR sensor. Now, I wired this right over here so that it doesn't block the LEDs or anything else from outside, so that we can check if these wires are wired properly. Now, what we'll do is check for these pins. So each of these are named as ground, power, and signal. As you already know, the ground goes to the ground, and here we don't need to use a resistor, as this PIR sensor already have a control of power. In real life it does as well. And then this to the 5 volts from the Arduino, red, and then this, this, and this one will pin into digital port 5, and I'll be changing this one's color to green as well. Now, this PIR sensor can detect motion now, but we cannot check if any motion is detected or not, since we don't have any code yet. Now, if I go to photodiode, you can either get the photoresistor or the photodiode. I find using the photodiode easier, as photoresistor can be a little bit tricky when we are using it for projects like this. In real life, I'll be using a photoresistor because it is much easier to use it in real life rather than in KiCad, because KiCad hasn't actually captured most of this stuff happening in real life into this simulation. So it has a bit of flaws, but yeah, we can work with it. And then we'll put this positive anode into the 5 volts and red. Now we'll wire this into that into the analog pin 0. So what the analog pin does is reads how much of an power or a voltage the digital pins can read ones and zeros and can give out ones and zeros as power. Analog pins can only read power in this Arduino board, as it says analog in. So that will help us to read the power from the photodiode, which will help us to identify at which point is there sunlight and not. Now I'll be changing this to gray, and here comes a bit of a tricky part in connecting these hardware, so keep in mind to follow along. So we'll be first putting in the H bridge. Yep, H bridge. Now, since we are connecting these ones, the ones on the bottom, to these power lines and the motives, I found it a bit glitchy when I used that side, so I'll be flipping this all the way around and using the enable 3 for input 3, output 3, that side of it. So enable 3-fold is what we'll be using to control the speed of the motor. And there's this special type of pins in the Arduino board which are denoted by this squiggle of a hyphen in front of all these numbers that are called PWM pins, pulse width modulation pins. These can control how much of a frequency of a current is going out through these pins. You can either give the full power out of those pins, or you can control it to a very specific value. So to control a speed of the motor, for example, you'll be needing a pulse width modulation pin, and here we will connecting enable 3 and 4 into pin 9, which is a pulse width modulation pin, or a PWM pin, which is denoted by this squiggle of a dash. And I'll be changing that one's color purple. So that's wired, and now we are going to input 3. So that's where all these signals from the breadboard will be coming into the H bridge to control the direction of this motor. So I'll be connecting that pin 13 of this Arduino board. There we go. And then that's how one will be connecting secondly, and to input 4 I'll be connecting it to pin 12 of the Arduino board. Now I'll be changing the colors of these wires since they are a bit different to what these wires do, even though they are connected to the same component. Now I'll be changing their color to blue. You can select any color you want. It's just for the easiness of seeing which wire does which and where each of one of them is connected. They have no importance in how much power they do or what they do. They're just to help us see what they do. We will be getting this power 1 into the 5 volts of this breadboard. Now we have 2 ground pins here, so I'll be getting another 2 resistors and connecting them here. Be mindful of these 2 lines of power. Since a resistor is a bit long, if you wire it in here along with these wires, it will be wired to the 5 volts, which is not what we want to. So we want it to be on the one above this, since that's the ground wire. Now this one will also have 1 kilo ohm. That's too much, so we'll be changing the units to 1 ohm, and we'll be using a 320 watt 220 ohm resistor for this. Ohms to 20, and now we get the motor and now we spin the motor around to help us wire this easily, and you can change this in any way you want. It's just for the easiness of wiring this. So the output port goes into that, and I'll be coloring it in blue as well. That into that, the output 3 to that, and our whole circuit is wired. In the next episode, I'll be showing you guys how to code this whole circuit. Thank you for watching this video. I hope you guys consider subscribing, liking this video, and also for other people to see these types of videos, consider sharing these videos as well. And catch you guys in the next one.